Yes, so there's that. So remember, we just have two steps in Gaussian elimination. One is there is a step where you do elimination, right? Use the pivot to cancel off, make zeros in the lower diagonal part of the matrix, and then you do back substitution. So this one adds the third step, which is you do partial pivoting. Which is use the largest value in a row, so in a column, as a pivot. Then you do elimination, and then finally you do back substitution. So the new thing here in this particular section is this partial pivoting, which I will illustrate with an example. So here's the example. Solve using Gauss elimination. The system of equations are x2 plus x3 equals 3 twice x1. Well, let me write it this way so it's much easier to understand. It's 2x1 plus x2 equals 8, x1 plus twice x2 plus x3 equals 8. So I just wrote it down in such a way that it's easy to parse all the x's are written, x1s are written the same vertical level, sorry, same vertical, same one above the other, rather, so that way you can easily see it, and the next is written one above the other, just to make it easy to see this. So once we have something like this, we'll try to write the augmented matrix. So the augmented matrix would have, well, in this case, there's a 0 in front of x1, so 0, 1, 1, and then the 3 from the right hand side. Then we have 2, 1, 0, and then 8 from the right side, and then 1, 2, 1, and 8 on the right side. This is the augmented matrix. Okay, so let's start or try to attempt Gauss elimination. So what Gauss elimination says is that go with the first column. So we have 0 to 1. Use the first element as the pivot. So use 0 as the pivot. But that's where the problem is. That is, you cannot use 0 as the pivot because you'll end up dividing by 0, which will lead to infinity. So what pivoting, partial pivoting tells you is that look at the first column. We have 0 to 1, and pick the pivot to be the largest of those two values. And when I say largest, it should be the absolute value. So even if there was, let's say, minus 10, so you take positive 10 as the pivot. So here, clearly, 2 is has the largest value, right? The second row, first column. So this is what we'll do. Row 1, column 2 has the largest value, which is 2. Use this as the pivot. Okay, so if you want to use it as a pivot, we need to move things along. We need to take the take 2, and we need to sub that with 0. We need to swap them because we always try to hit ones in that place. We want to have everything below that 0. So what we need to do is we need to switch row 1 with row 2. And the good thing about switching equations is that switching equations doesn't really change anything. It's provided you switch the whole thing. So you need to pick the entire row and move it out. If you only pick some part of it, then there's a problem. So we'll switch row 1 with row 2. So the way you can write this is this way. And so when we do that, we end up with 2108. So look back, 2108. The next would be 0113. Next would be 1218. Okay, so that's the first step. That's the partial pivot. The second step is elimination. Okay, we want to use the 2 to eliminate any non-zero elements in first column. Now, the good thing about this step was that we already ended up with 0 here, so we don't have to do much work, any work there, right? So you only have to eliminate this one. So what we'll do is we'll do row 3 equals row 3 minus, well, you take the pivot, divide by the pivot 2, times this 1 times row 1. So always the pivot comes here, and then this thing, whatever is here, will always go there. Okay, so doing that will give us the following. The first row is unaffected. The second row is unaffected because we already had the 0, so we didn't do any work on that. And now the third row will have 0. Then we'll do, so I'm just using this formula, row 3, 2 minus half row 1, 2 minus half of 1, so 2 minus 0.5, that would be 1.5. Then 1 minus half of 0, so 1 minus 0 is 1. And then 8 minus half of 8, so 8 minus 4 is 4. So this completes the first step, which gives us what we wanted, which is we're just beginning to form that triangular matrix, upper triangular matrix, right? So we now need to work with this, get rid of that. So next step, we look at column 2. In order to do pivoting, even though none of the elements here are 0, and it's perfectly fine if you want to skip pivoting here, but we just want to use the algorithm in a way that it can be generalizable to about any situation, right? So we will do the partial pivoting because in our code, we will not distinguish between 0 and non-zero. We'll just take the largest value. So 1.5 is the largest value in column 2. Okay, so we want to choose 1.5 as the pivot. Now, when you're choosing this pivot, you want to switch that with everything which is below this particular row, right? Because we don't want to touch these. So we take row 2 and switch it with row 3, and then we'll have 1.5 is a new pivot. That we don't really touch this element because we don't care about that. It's already in that form, which is upper diagonal. So since row 3 column 2 equals 1.5 is the largest value, we will switch row 2 with row 3. Okay, so I'll write it down on a new page. first of all, the first row is as is, so it's 2, 1, 0, 8. Next, we switched row 2 and column 2 and column 3. So we need to move this row 3 up. So 0, 1.5, 1, 4. 0, 1.5, 1, 4. Then we move the second row down. So 0, 1, 1, 3. Yeah, now we're all set to reduce this 1 to 0. So we use 1.5 as a new pivot. And we do this calculation, which is row 3 equals the old row 3 minus, always divide by the pivot 1.5, and then put this 1 over here times row 2. This went here. This went here. And now let's write this down. So the first row is unaffected. The second row is also unaffected. Third row, you'll see that this 0 is always remains 0 because there's a 0 on top. And then 1 minus 1 divided by 1.5, row 2, that's going just simply 0. Okay, and then we need to do 1 minus, so 1 minus 1 minus 1 divided by 1.5 times row 2, which is 1 minus, that's 2/3. So it looks like it is 0.6667. So 7. And then we have 3, row 3, minus 1 divided by 1.5 times row 2, 4. So this looks like it's 3 times, it's 8 divided by 3. So it's going to be 1/3. I think I got this wrong. Let's do it again. I think this is wrong. So this is 1/3, but I think this is not right. Let me, from my notes, let me just redo this one. So this is right. Let's check this again. So it's row 3, which is 1, minus 1 divided by 1.5 times row 2, which is 1. So 1 minus 2/3. 1 minus 0.6667. Yeah, it's 0.3333. My bad. This should be 0.3333. Okay. Yes, I'm just deleting that to prevent clutter. Okay, now we are all set. We just have what we wanted, which is the upper triangular matrix. This is what we wanted. We have it there. So the final step is elimination. Sorry, back substitution, my bad. Back substitution. Okay, so from row 3, we have 0.3333 x3 equals, I don't know if this is clear, but let me just put this down. So what we have reduced this is to this system, right? X2 equals 8, 1.5x. You know what? Let me just write it down. I think some people will be confused when I try to directly do this. So this thing, what I've written down is simply 2x1 plus x2 equals 8. Equals 8. 1.5x2 plus x3 equals 4. And then 0.3333 x3 equals 0.3333. I just rewrote those three equations as ax equals b. Okay, so now it's maybe easier to see. From the third equation, let's call that 1, 2, 3. So from 3, we have x3 equals 1. From 2, we have 1.5 x2 plus x3 is 1 equals 4, which gives me x2 equals, I think it's 2. And then first equation, we have 2x1 plus x2. x2 is 2 equals 8. So x1 equals, I think it's 8 minus 2, 6 divided by 2 is 3. So the answer is x1 equals 3, x2 equals 2, x1 equals 1. It's your final answer. Okay, so last time I wrote this code, well, I got ChatGPT to write the code, which solved a different problem. And that was, we were able to get the solution. So, and I briefly showed that putting one of those elements to 0 does not work. So what I'll do first is just take this code. This is basically the main file which runs Gauss elimination. And this is basically the Gauss elimination method. So first thing you want to try is see what you have, which is this one. It's a different problem. So change this with the current problem. The current problem, if you look at the equations, it's 0, 1, 1. The second row is 2, 1, 0. And the third row is 1, 2, 1. Okay, and then the right hand side is 3, 8, 8. And let's save this. I need to save it in exactly the same place, otherwise it will not work. Numerical methods. Pictures. Let's call that width. Paper. Okay. So run this, and I'm not expecting it to work. Change directory. Okay, so I saw this using two methods. One is using the inbuilt a/\b. That gave me answers 3, 2, 1, exactly what we computed. But if you use Gauss elimination, something the code which we wrote last time, it actually gave me another number. And that's because it uses the 0 as a pivot, which does not really work. So what we'll do is we'll try to fix this code, which doesn't have the partial pivot. Basically does the forward elimination and it does the back substitution. Okay, so the good thing is that all our chats are saved. So this is Gauss elimination octave. It gave me this code. So what I'm going to tell it to do is modify Gauss elimination to perform partial pivoting. Okay, so it looks like it's doing it here. Gauss elimination partial pivoting. Okay, I think so. The best way I think I can understand this is to just make it print the results every iteration. I don't really care about the second part because that we change the problem here. This is not a problem, but we want this. So let's take this code, make a new file. Let's call this with pivoting. Save. Now it's very important that you save with the same name as the function name, otherwise it will not run. Let's take this and then switch the function call and then run this. Okay, so you can see x is 3, 2, 1, and then we say solution for x1, x is 3, 2, 1. Okay, so it worked fine, but something which you want to do is you want to be you want to see that what it's doing checks with our calculations. So you can do that actually quite easily. So if you go here, see what it's doing. It's doing the augmented matrix. Then it's doing the partial pivoting. It's finding the maximum of each row. Then it's swapping the rows. It's performing elimination, and then back substitution, exactly what we did. But if you want to see the output, what we can do is we can make it display a few things. So we'll say display initial augmented matrix. Yes, so I just want to make it print augmented matrix. So that's what the problem looks like. Then what we wanted to do is perhaps let it do partial pivoting, so switching. Let it do, well, it finds, sorry, partial pivoting just finds the row with the maximum, the largest value. Then it switches the row. If you want, you can print it there. And then it does the elimination. But, we're just better off putting it here. So this should correspond to each of the iterations which we solved. There'll be like 2 of them, right? So this is elimination. And then before it's done, so it's just ending the function. It's hard to say. So for ends here, for ends here. What does this for end? I think it's the function. Okay, so final. Okay, so I think this will help us understand this better. So let's run this. It won't print. Okay. Elimination. Okay, so here we have a problem with the output, right? So let's use the trick we used before. So we're going to say diary output.txt, and then we'll say diary off. So if you see here, the original place, you don't see an output.txt, but the moment I run this, it will create a diary. So sorry, it create an output, and we can look at the output to see what the results are. So here it is. Okay, so this 321 came because I used A for \B. So our initial augmented matrix was this. So you can see there's a pivot 0, which we don't want, so we need to switch. So it's switching second row with the first row. So you can see this 2 went up, the 0 went down. You also see that it starts showing these 0, 0, 0, 0. That's actually kind of interesting. It actually converts these ints to a double, right? Because it has to do this 1 divided by 2 and so on. And so this is where there is something called round off errors, which we'll talk in sometime later, which will occur if you are not careful with this. But for now, just ignore that. So we have 2 and 0, 0, just like what we did in the calculation. Then what it does is it figures out between 1 and 1.1 and 1.5. 1.5 is the largest element, so it switches 1.5 up, puts this is actually after the back substitution. So it switches that first and then eliminates the 1. So I've just shown output for both those calculations, but you could split it up into 2 parts, and then you get this matrix. This is exactly what we got by hand, right? And then back substitution would mean you solve them backwards to get 3 to 1.